Hello, everyone. Today, I'm going to follow up with a series of Linux how-tos on compilers and interpreters. The first video that I posted already was compilers and interpreters on Linux Ubuntu. So let me go through a slideshow on this video, and we can continue with this. We have already posted the Linux how-to on compilers and interpreters for Linux Ubuntu, and that was video number 13.1. You should watch that one and enjoy it and learn it, and then make some comments. The next video that I covered was Linux how-tos on compilers and interpreters for Rocky Linux Enterprise version of Rocky, and that was video number 13. And then on that video number 13.2, actually it was video number 13.2 dash 2, and then that was covering Rocky, and coming up next was RedHat. So tonight I'm going to cover RedHat on compilers and interpreters, and this video will be posted tonight, video number 13 dash 3. So that would compile, cover all the compilers and interpreters for both Linux and Red Hat, as well as Linux Ubuntu, all three of them. So first, let's discuss what is a compiler. A compiler is a special program that translates a programming language source code into machine code or bytecode or another programming language. So basically, you get a source code like a Java program, you compile it, giving the Java C compiler, and then you get a class file, which is a bytecode for the source code of your programming Java. You compile a C program or C++ program. Also, you get a machine code out of that one, which would be executable binary files that you could just get it. So basically, when you get a source code of C, C++ source file, either the extension of .c or .c++, which I'm going to demo that one at that section, and then you create an object file and then link it with the LD libraries, all of them, and then get the assembly code as well as the object files as well as executable, which is called ELF, executable link format. And then sometimes you could also compile it into another programming language. So I'm going to show you in terms of interpreter, for example, in Python. Sometimes you just for native code of C or C++, in order to just make your code on the interpreter faster. And so you write that in the module, for example, regular expression or NumPy, you write it in C, and then you compile it, and then now the module that is loaded in Python, which is an interpreter language, is much faster because it's native C code. I'm going to demo that as well. What is an interpreter? An interpreter is a special program that can analyze and execute a program line by line. So it reads the first line of the code, and then if it has any error, it's going to just detect it, and then it's going to give you a prompt to just correct it, and that is a syntax error. Semantic will not be caught at compile time or interpreter time in this case, and then that would have to be checked at runtime. So the syntax will be checked at the interpreter level, and then at the same time it will analyze it. If it is good, it will execute it. If it's not good, it will throw an error till you fix that line, and then it goes to the next line. That's what an interpreter is. And then now I'm going to talk about comparison between compilers and interpreters. Why do we have compilers? Why do we have interpreters? What are the differences? First of all, the main difference is compilers are, since they're compiled code, the source code is given to the compiler at once, and the whole thing is, if it's one page of a programming language that is written in C, Java, So any programming language, that Go language, anything that you compile it, they're all kind of the source code is compiled at once. So if any error at any line that is generating, the compiler will throw an error. You have to correct it, and then you compile it. If the compilation is completely done, the compiler will generate the object file, an executable file, or a bytecode file, or another native code, or a executable link format file. And then that one will be running in machine code or assembly language and converted to zeros and ones, and the binary will eventually execute. So that executable code, if it is in terms of Java, it will be a bytecode. The bytecode, you need a Java virtual machine kind of interpreter that it will compiler that would actually compile it, and then the next machine that you are loading it on the processor, you have to have the Java virtual machine, which is called Java, and then you run that one against it, and it will compile it. So compiler is much faster than interpreters. However, interpreters are slower in terms of compilation or interpretation, because it gets one line of code, it tries to interpret it, it analyzes it and executes it, and if it's successful, it will give you an output. If it doesn't, it will throw an error. So the interpreter, since it's line by line, if you have 100 lines, it has to go through each line one at a time. If it has 2 lines, it has to find out, analyze it, and do that first thing with analyze and execute on the first line. If it is successful, then it moves on to the next line till it finish the whole program. So interpreter are slower, but you could write a kind of native code, like I mentioned, NumPy and regular expression and other modules that are in Python that are written in native C, and you can just use those modules inside Python. It still will just do the array structure much faster, because it's all written in the same data type that array is defined. It's not like a list that Python has all different data type within the list, but it's within array, it is all same type. So if it's integer, it is integer. If it's float or character or a string, anything that is defined, they're homogeneous type of data type, not heterogeneous. But with list, it is heterogeneous, so that's why it is slower, because there's a lot of overhead to work with it. The interpreter is slower. However, like I mentioned, NumPy, regular expression, there are some native code in C. C has is the mother of all languages. Basically, a lot of the programming languages that were built in, including the Unix operating system, were written in C. C, an assembly language for device driver, is very fast to do kind of like codes that are fast, and then sometimes game programming were written in C++ for the speed of it, and also the functionality that it has. So every interpreter, for example, Python is winning against all other interpreters, Perl and PHP and other stuff that you could look at them. But Python is better because it has support for so many modules, thousands of modules. It allows you to do scientific programming, as well as data science, as well as artificial intelligence. So we will discuss a couple of those ones as well here to see what we can do with Python as well. And then, so the main difference is the compiler programs or generating executable files. Interpreters are running one line at a time, and then compilers are faster, interpreters are slower. Compilers or just compiling the entire page of your source code at one time, or if you have too many pages, it will compile all of them. Interpreter just does it one line at a time. So now example of compilers There are many examples. I'm listing some of them here. So assembly language or assembler, NASM is one of them for compiler. And then AS is for assembler itself, LD for loader or linker, that you could link your object files with it. And then C++ also generate the object files, and then files like a.out or some file that in Windows.exec for executable, or in Unix and Linux, you don't have to give any extension by default. If you just compile them, they're either 32-bit or 64-bit, depending on your compilers, and then you could create executable link format, ELF format. And then the compiler that is very known is the GNU C collection compiler, which is GCC, or GNU C++ collection compiler, which is G++, in this case, the compiler. We also have IDE, Integrated Development Environment, and there's a lot of them, and I'm just listing a few of them here. One of them is Visual Studio Code, which is the Microsoft Visual Studio Code lightweight version, which is open source Visual Studio Code. The other one is JetBrains, provided by JetBrains. Xcode, provided by Apple, and then CodeBlocks, which is also, I believe, provided by CodeBlocks itself. And then Rust is another programming language. The nice thing about IDE, they provide you integrated development environment, so you can develop your source code. You could have an editorial. You have like options to just make sure that if a library or something is not available for you, you could just load them and install extension and a lot of other things, and code kind of option for code reusability, and then there's so many IntelliSense and so many other options that it has. So Rust is a compiled language also, and Rust C is the compiler, and I will show you a demo on that one as well. Java is Java programming language, is also object-oriented programming language. This was built by James Gosling at Sun Microsystem, and then it has been a very good programming language. It's one of those, all of these programming languages that I marked it in red and or dark red, or kind of hot programming languages that are being used by millions of developers all over the world or the globe. And so Java C is the compiler for it. Java itself is the virtual machine for it, and then there's jar files, Java archive files, and then applet files that are there, and then Java has a number of standard development kit, which is open JDK, and then Java runtime environment. So depending on what platform and where you have, you might have either downloaded the client or the server side and then built your source code. Go is another programming language that was introduced back in 2007 by Rob and Robert and Ken Thompson at Google.com or Google company, and that's why it's called Golang, for Go language, and Go is abbreviation for Google programming language. Google Docs also has, Go Docs is also for Go language documentation, that when you install Golang, you get all of those Go, Golang, and Go Docs binaries, and then you can use them. I'll demo as well Go language today. Fortran, Ada, Pascal, COBOL, Lisp. Fortran is very, very powerful in terms of scientific programming, and then we use it at Jet Propulsion Laboratory, jpl.nasa.gov, and then we are using C++, Rust, Java, Go, a lot of these, assembly, everything that you can name. We use it for various robotic and mission critical software and applied ops and other and software. And Fortran, Intel Fortran is also used on the HPC, which I work on those ones as well as an admin. And it is HPC stand for High Performance Computing. We work on it on TAC, which is Texas Automation Supercomputing Environment. That's also high performance computing environment, Frontier and the Lone Star 6 and all other ones, or the supercomputing that University of Texas provide us. So the Fortran, Ada, Pascal, COBOL, Lisp, I mentioned it here, and then you can see Ada, Pascal, COBOL, and Lisp are a little bit kind of bluish color, which means they're not as hot, and they're just kind of like going away. Especially Ada was introduced by her. Ada was her name, the first programming language at the defense and military part. But back when I was a student at Cal State Fullerton, when I was studying Bachelor of Science, I took 2 courses of Ada programming, and that was at Cal State Fullerton. And then as sophomore or junior, I took 2 courses of Pascal programming language at City College, New York, and then 1 course of COBOL at Cal State Fullerton, 1 course of Lisp, and then C, C++, and Java. I don't remember if I took it at college, but I taught myself at work in other places. And then C and C++, I have worked a lot on it, especially I have taught classes also on Unix and C++ and C, Bash scripting and awk and a lot of Python. Python just at Pasadena, I taught 5 semesters of Python, 1 course of C++, and then a number of C and C++ and Visual Basic and other programming languages, our operating system and compilers and databases, MySQL, Oracle. I taught at National University, Cal State Fullerton, and then Computer Learning Center. In the past 2 years, I taught some of these courses also at Pasadena City College, especially Python and C++ and Unix Bash scripting. I taught those ones. So I'm going to cover all of these ones there. Lisp was very good for recursive programming that you could write function calls. It's kind of common. Lisp was object-oriented version of it. Lisp is recursive function calls that you could do nested list in nested functions within another function. Common object business language was COBOL. That was for business, and it looks like it's gone. COBOL 90 was very famous back in 1990. And then Pascal is the mother of all language, similar to C. And C++. C is the mother of all language as well as Pascal. Once you learn Pascal and C, you can learn the other languages much easier, especially C. The for statement, while statement, function call. So C is like C, C++, and then Java, and then JavaScript. A lot of the languages, they borrow some of the syntax, including Go language and Java and other ones. And then sometimes, using, like, for example, one function in Ruby, you might say put this, and then in Python, you might use printf statement. So a lot of the language are kind of similar. Once you learn one, the other one is easier. Swift is also, and Apple is using it for iPhone and iPad and Apple related Mac OS X version. Objective-C was at one point was really good, but then because of these other programming languages taking over, the memory management of C++, for example, is not as efficient as Rust is, and the memory leak on Rust is much more manageable. So Rust is, in one sense, is an alternative to C++, but because there's millions of people have already worked on C++ and developing and really there's a lot of codes. People are going to continue using C++ because it has a lot of nice features and functionality that none of the other programming languages might have ever had it. But because the new programming languages that are written, like for example, if you look at Python, Python is very cool. It's very easy to learn. It has a lot of module or C# or something, but then they are written in C. So without C, they wouldn't exist. Or Rust, for example, does a lot of things that C++ does. The beauty of Rust is that the syntax and kind of usage is very easy like Python, but the speed of it is very efficient like C or C++ in terms of speed. So in that sense, you gotta learn everything because you never know what company is going to ask you to write what software, and then if you're writing for your own software from time to time, you might have different reason to use one versus the other one. So let's go to the interpreters example. Python, interactive Python, which is called IPython, and Jupyter Lab, which is a web interface for Python that has some new features for interactivity, which are called aliases and ls magic stuff. Both IPython and Jupyter Lab provides it. And then they're cell-based, sometimes the ls magic, and sometimes different type of Jupyter Lab. Reason is that since you're doing IPython IPython or Jupyter Lab or Jupyter Notebooks. Jupyter Notebook was a little bit older version. It became legacy. Now Jupyter Lab is the most useful one that has a lot of the features that Python has. But within Python, you could take advantage of all of them. And Python has its own idle search engine, or idle interpreter, which is called Integrated Development Learning Environment, IDLE. Or sometimes the Python, you could get the IDE for it for PyCharm or Visual Studio Code, VS Code. So you could get the IDE and you have everything that you can have that built environment. You can build your source code and write applications. JavaScript, cascaded style sheet, CSS and HTML, hypertext markup language. They are all available on the RedHat, Linux Ubuntu, and Rocky, and then we could demo as well those ones. PHP is also a professional homepage. At one point, that was very good interpreter that was available, and it is still available. The syntax is much like C. I was mentioning earlier, Java, C, C++, but PHP is another one of those ones. But within PHP, you could write HTML code and then less than sign question mark, and then start off with PHP syntax. And then inside your HTML tag, you could have PHP code. Similarly, inside HTML code, you could have CSS or put a link on the CSS file, or just within HTML file, you could run JavaScript and compile a source code within the HTML code, or write JNode that you could just have a React software. So there's a lot of features and functionality that are available. Ruby is another interpreter that is very good. Ruby and PHP for the web are very useful. At one point, Perl was very, very useful. Back in 2000, I was working on a web hosting company, and we had maybe 120,000 domains that we were hosting on 4,000 servers. And then some of those servers were a Linux server, some of them was SGI IREX, some of them Sun Solaris, some of them were Windows, some of them were Linux, Red Hat, all of them, and they were just using Perl on the CGI part or the programming for the web interface. And then some people were writing, obviously, Bash and Corn Shell and other ones. And then at the same time, PHP and Ruby. But Perl was very, very much used back in 2000. However, at some point, Perl has become a legacy. So starting at version 5 point something, active Perl and Perl, which is Perl stands for practical extraction reporting language. So it was for that purpose. Similarly, like awk, it was awkward scripting, which is does a lot of things in just one line of syntax. You could do a lot of those things in a faster way, similar to Bourne shell, Kern shell, Bash, C shell, through C shell, or ZSX shell. But Python took over. Python, if you want to do a lot of modules and build apps similar to like a programming language like C, C++, Java, and then take advantage of the ease of use, you could just enjoy using Python. R language is another programming language that is for basically statistics software and a stock market and other ones that you could do scientific and formula computation. MATLAB and R language are very much used in the industry, and R is also good. So we're gonna just go to the next session, which is demo on the section on Ubuntu compiler. Actually, this is not Ubuntu, so I'm gonna correct that one, and we're gonna cover tonight the Red Hat. So let me just go and modify that part right here on Red Hat. And then I'm gonna just size this one a little bit bigger so it fits on one side here, and then save this one, and then come back here and say slide, and then we save from current one. So this is what we covered, the interpreters, and then we said we're gonna go to the demo section on Red Hat. So just correcting that one, we're gonna go on Red Hat, compilers and interpreters, and let me show you the Red Hat server. And this, before I show you the Red Hat server, just letting you know that the channel you're watching is called My Web University. It's my YouTube channel at YouTube, and it's my Web University. And then so far there's more than 1,100 videos that I have posted in the field of computer science related courses, whether it's operating system like Windows or Linux or Mac OS X or Unix or Solaris or Linux Ubuntu, Rocky version, Linux Red Hat, or a lot of other type of maybe virtualization, installing from virtual host and creating VMs, and then sometimes operating system, and sometimes databases like MySQL, sometimes programming language like C, C++, Python, or Bash scripting, or shell scripting, or documentation that are all available at my webuniversity.com, this website that is a secure page, so you can go there. And then a lot of these, this is a book that I wrote, and it's called The Direct Path to Linux Ubuntu. The entire 9 chapters online available for free. You're welcome to use it. Each chapter by itself is another book. For example, if you look at the chapter 8 of my book, I provide you the entire 6,500 technical documentation in a nice PDF format. So whichever command you click on, you get a PDF file. You could just go start reading it until the end. Like this one is 65 pages, so you could get that one. And then if you just go here, like let's say you click on this, and then you just get that output there. Whichever one, is section 1 through section 9. So if you look at this one slowly, if I move it here, I can move it slowly because 6,500 is a lot of it. But notice how this is giving you all the information. So if I move this one faster, you can see for each section, I have made a nice table for you that you can say section 2 of the manual pages, for it. And then if you just click on any of them here, nmap is or mmap command is there. It is just giving you the output here. So some of them could be 400 pages, some of them could be 2 pages or 100 pages or 1 page there, and just look at them, and then this is the file. So if you just are in the mywebuniversity.com, you can also get the C and C++ header files, which is normally it's not available. But when you come to mywebuniversity.com, the nice thing is that I made everything available for you in a PDF format or HTML format or a CSS output that is giving you in a nice kind of tabular form. So you just click on the header file and then just come in here and then read the header file. Usually you have to be logged in to a Unix machine or Linux machine to read these files, and I make it available through a browser for you. Because I wrote I did all the heavy work on writing a program to create these kind of files, and so I did a combination of Python programming, JavaScript, and CSS, and shell scripting to generate all of this. And then as you click on it, it just gave you the output based on whichever header file you want to read. And this is for C and C++, both of them, as you can see here. And then also I have chapter 7, the entire Linux manual pages. So you are welcome to search them by the thing that you search. So if I do Control+ to make this screen a little bit bigger, and as you type in, for example, you type in the command pmap, process map, you can see the output is going to be giving you here, pmap process map. Or you just say, how about systemctl? Systemctl. System control is the systemd daemons, and it's going to give you. And when you read these ones, everything that is related to it, you read the whole manual pages, and then you can go to the see also section. As a student, you might be just interested to know more about it because there's so much and you're learning it. So read the see also section of it. And it says, well, you can also learn systemd manual pages, journalctl, log this, firewall D, and so on, many other ones that are related. And then you just say, okay, yeah, I like to see, for example, this is Ubuntu, firewall D is not there, but on Ubuntu firewall is there. So if it was RedHat, so Ubuntu firewall is that man page, but you could get the systemd, which is systemctl, that is going to also give you systemd in it. And it was the System 5 release 4 previous version, and starting at RedHat 7 and then Ubuntu 16 and other ones. Developers of those vendors, they decided to use systemd. So systemd has been replacing init, which was RedHat 6 and 5 and below. And that was the mother of all process that starts similarly on Linux machine. Systemd is the mother of all process, which is process ID 1. So, and then there's a scheduler, there's a lot of daemons. The reason that this D is that the daemon process, it runs in the background, those ones, monitors all your system activities. So, and this is good that you wanna just find out on this book. I also have on the same book a lot of shell scripting, a lot of Linux and Unix commands that you can learn. So if you look at chapter 5 is Unix shell scripting, and that would teach you shell programming, and I have other videos that I have there. I want to show you just chapter 4, advanced Linux Unix command. This is another useful things for advanced Linux operating system. So if you're not novice or intermediate and you want to learn more, and this is the chapter that will help you with your advanced skills. And then there's command like list of open files, gcore or PM, pkel, screen, make, doing a LD or executable link format. So you can see that the file system, there's a lot of commands. And then there's group add, user add, and all that. I'm explaining here that line by line, you could learn it. And then for each of these rows, I also have these section here. For each one of the row, I have part one of this would be part chapter 4 part 1 from the first row. This would be chapter 4 part 2. This would be chapter 4 part 3 up to chapter 4 part 8 of 8. So there's 8 rows, and then I have 8 videos here. You're welcome to watch them, and then part 8 of 8 would cover the last row. And then at the same time, if you want to just learn something, like for example, let's say you're looking at a command that is called curl. And if you just say, what does curl do? Then I'm just giving you curl and then the syntax, and it says curl dash dash help. It gives you help on it. And then let me just make this one a little bit bigger so you can see it better. And then as you can see here, what is curl? It says transfer your URL. And then example, I'm going to give you some example here and just say curl dash dash help. So when you do click on this one, I run the command in my Linux or Ubuntu server in the cloud. And then I say, you provided this command and this is the output here. So every command that you do, I execute it for you on my Linux server. And I provide you back the through the Python program, the output back on the screen. So and the entire thing is formatted properly for you. And if you say curl dash dash manual and just says that you click on that command, here was your command, curl dash dash manual, and here's the output for it. So I run the command similarly and this way. And then if you say, well, that's good, I'd like to see if I can get the manual pages for it. So if you look at this curl man, I just take you back to that chapter 7, and then I just give you curl manual pages so you could understand and read it in there. So this is not just for chapter 4, or let's say another command is here, print working directory of executable. So when you click on that one, it says it runs show the process of executable, and you click on it, and actually PWD of executable file, whether it says that what is my CGI bin directory, it says user left, that is the process ID that this is running off of user left CGI bin. So there's a lot of neat stuff you can learn, and then if you want to say, give me a manual pages of it, I just give you the manual page for PWDX. It's very useful if you want to learn Linux and Unix. And then if you want to go say, okay, I learned that one, let me get the intermediate. I have a lot of stuff on the intermediate as well for chapter 3, and then chapter 3, these are the commands. So if you want to say, for example, what does the command base name do? For example, you could just type in base name and it tells you the output here. So base name of their user bin sort, it will just give you the user bin, because that's the base of it. The dir name is this. Sorry, dir name is that. The base name is sort. So and that would be there. Since I click on the dir name, I get the output there. But if I click on the base name on the commands, let's say, for example, base name of this one, it will show sort right there. And similarly, if I look at the base name of date command, it will produce date. But the dir name would be user GNU bin. So sometimes you could use cat or awk to just do it, but sometimes these utilities or programs does all the thing for you. And then at the same time, if you're looking at the manual pages for it, I take you to the manual pages and read the manual pages. So that is for all those chapters. And if you're novice or beginners, then you're welcome to read chapter 2, basic Unix commands. and some of the commands are here. 33 commands like cat command, calendar command, and everything. So if I click on calendar command here, you can see that it is giving me. So I did show you these ones because of all these documentation that I have already made available for you. It is on my website as well, but I'm gonna just cover the Linux Ubuntu Linux Red Hat compilers now. So let's get started with that algorithm. I'm gonna go on this virtual machine that I have already logged on. I have already set up my environment, so I can show you what we are going to do. I need to log in again because the screen saver kicked in. So as you can see here, if I say uname-a, it will tell me that I'm on a Linux and the revision build is this. So if I say uname-r, it tells me that the revision uname-o is going to give me the OS version GNU. And then there's a lot of uname-help will give you all of that one. I'm not going to go through all of that, but what I'm going to show you cat-m etc os-release. This os-release, it tells you that the version is 9.2, and then the platform is Fedora, the distribution is Fedora Linux, and then it is Red Hat Enterprise Linux 9.2. The code name is Flow. So this is what I want to show you, that we're running this. You can also clear the screen, and then just instead of this, you say Red Hat -release. This also tells you that it is one line short version. It says Red Hat Enterprise Linux there. The file etc star release tells you there's some files here. Is OS release, Red Hat release, and system release. System release is the same thing as Red Hat -release. So etc system -release, in this case, a symbolic link to Red Hat -release, and Red Hat -release, we just calculated it was this file. So that we know that information. Now, in order to just continue on, I need to say what directory I am. So let's just get started with this directory first before we do anything else. So this is my shell scripting. I want to just show you first all the files that I have .sh or in this one, and then every file that is .bash is here, and every file that is .c shell. If I have anything with .corn shell, I could list it. If I don't have it, I don't have it. I could write it, whether you write it in Bourne shell or corn shell or bash or zsh, the syntax is important. So you just have to do it that way. Let me just clear the screen here. I'm gonna just show you, this is the directory I am. And then I wanna just say, there's a file called welcome.sh. So that welcome.sh, if I just want to run that one, clear the screen, say welcome.sh, it's gonna just say about 10 times welcome to my YouTube channel, my web university, and then it does a different coloring scheme on the font, and so everything that I display, I get a different color. And then the laugh out loud is the utility that I just use against the font. Notice every time I run it, I get a different set of colors, which is nice, and that sense that you can play around with it. But cat-n welcome.sh is the entire program is this. So when you look at it, these files on the shell scripting, I have also demoed. You can see that it is written on that purpose, and then it goes and does a modulator divisible by 2. If it is the remainder is equal 0, then it's an even number. I do a certain type of color, and if it is not divisible by 0, then I do the color with laugh out loud cat dash t. And then this which laugh out loud cat command is a utility that you can do. For example, if I say this and then I say laugh out loud cat, it will change it a different color. So whatever command you type in, here I type in this and then I just pipe it to laugh out loud cat and then I just get a different output. ls is this, and then if I say laugh out loud cat, it is going to change it to different color. Okay, so depend on what you want to do with it. Clear the screen, and then I'm gonna demo the laugh out loud cat and details when we get to apps and utilities. So at this time, I want to just get back to the actual other tools. Let's get started with awk first, because the way I want to do it is this awk is there, then I'll jump back to the shells, and then I'll do that, and then I'll go through those rest of them. So I have a list here, ls, and then if I just do this, you can see pwd and ls is those ones. But notice this pwd, if I just want to get this information, I could also do pwd laugh out loud cat, laugh out loud cat. That would just give me that output. But what if I want to do that command and also do ls command? So now notice that the pwd, this portion, it just does this. And then the ampersand, meaning that once the output of this command is run, also run this command, ls, and that would do it. So every time I run it, I get a different output for pwd because the color is going to change. So I know that I'm getting that output. So at this time, we're going to just go to the awk directory. Go to the awk directory. And so this is another nice thing that you could do, just using that dir name and base name. So if I just say awk pwd and I say dir name, I'm sorry, awk pwd, and then I'm gonna do this actually, dir name and then pwd. So this is gonna give me the dir name, but if I'm interested on the base name of pwd, base name, then it's gonna say awk. So in order to do this, I could say pwd, and then I say pwd, and then ampersand, and then a base name pwd, and then you could say ls. And notice that this time I did this for the actual pwd, and then run this one, and I just gave pwd rather than a base name of current pwd. Let me try this, and that would be clear the screen base name, clear the screen base name of pwd. That gave me awk, and then I could do like grep minus I awk. If I want to just make it in the red color, for example, you could do that one. But depend on what you want to do with it. But at this time, let's just do something like this. So I could say that's good enough. I will do those kind of things when it comes to other utility. Let's say go to the CD to awk, and then at this time, let's just demo awk programming language. So in order for you to write hello world in awk, you could just say echo hello world. This is just in the bash. that you could do bash scripting, and then echo hello world would do it. But if you want to just put that one into awk as input, you could say print, and then $0 would be the same thing as that. So whether you type in $0 here, awk would understand that you're writing that. But if I want to write $1, then it's going to say hello, and $2 would be saying word. But if I want to get $1, $2, then it will write both of them. So why not just write the $0 to get both of them, the entire line, or not even write that one. By default, it does the same thing. So if you just do this one now, if you do laugh out loud cat, it will just write it in color. That would be a little bit more meaningful there. So the next thing that you want to do is awk is there. We could also write awk for as a program. So like look at the hello.txt. It just says hello awk, right? So if I just cap that one hello.txt, cap is concatenation of the contents of hello.txt. I can also say awk and then print, and then you could say hello.txt. So that's the same thing as cat. Catting the file here is the same thing as running this command. Awk print and then the name of the input file. In this case, hello. Earlier we were using pipe, and now we're using the input file here. So another way you could look at the content of that one, but look at the hello.awk programming. That one has a print statement, and notice that I'm using shebang here, which is saying that use the shebang #bang, use a Benny B, and then load the bash interpreter. And once you load the bash interpreter, then run the awk print statement hello.txt, which was this statement that I did here, awk hello print .txt. Since I'm inside the bash, I could do that way, or I could say environment bash and then load that one. So now I could say hello.awk, it will just do the same thing, hello.awk. Whatever I write the syntax of it, it is going to do that. So clearing the screen, cat hello.txt is that, but then this one will say hello.awk, and notice that hello.awk, it uses this input file as the argument. So if I say echo, and then I say welcome to my YouTube channel, that's good enough. And then I'm going to send it to the file called hello.txt. Now hello.txt is there. We just dynamically load that string, and if I call it now, it's going to say welcome to my YouTube channel. So whichever string that I give the input file and say hi, thanks for watching our channel. So when you do this one, and you just write this one, now you just run the code, it will just say, hi, thanks for watching our channel. That's how dynamically programming is going to read the input, and it's going to parse it, and it's going to do that one. So the next output I want to show you is this data file, what is, and there I have 100 lines. So if I just want to say, do that one for cat for demo.awk, and then I want to say for demo.awk, it basically print that numbers within the for statement. So if you look at the source code of this one, it says for I is less than 5, I++, and then it says your lucky number, and then it uses that int random number generator to do that one, and times the random number generator, and then generate these files here. And so the other file that is using while demo.awk, this is using the data file. And as you can see, the data file was baked. So if I say while demo.awk, it runs all those 100 numbers. But if I say sequence of 10 greater than data file, now sequence 10 is going to generate 1 through 10 the numbers. So if I say sequence of 10, that means write 1 through the numbers with that greater sign to the data file, 1 through 10. So now if I say run the while statement, it's gonna just do that. But let's just correct something here. Then while demo.awk, and then as you see that I wrote this one, disregard to what number I'm checking, I always set the I is equal 1. So I'm going to move this one outside of this to see if I could just do that one, and then only print when number is less than 3. Let's do that. And there you go. Command not found. I is not found. So let's correct that one. Then while demo.awk, looks like this one is not inside the awk, so it does not read it. I is not defined here. And then if I just don't set the I equal to this, it will not know what it is there. So you just need that one there. And let's say I'm going to say while I is less than 5, do this. Data file is there. And now we run it, it's going to run those ones. But notice there's more spaces in one case, and then the other one is not depend on how we are going to print it. Cat data file and cat while demo.awk. And so in here it just says while I is less than 5, print I plus. If we want to increment it, we could increment it here, or I is equal +1, and we could do that one. Depending on what you want to do with it, those all statements that everything you could do is depending on the usage of what you're planning to do. So there's hello.awk I already provided, and then I'm going to show you another way of this program that you could do interactive awk programming. So like for example, if I just do a PWD here, I could say PWD, and then I could say cut minus D, and then slash, and then minus F1. So that would just give you those, and then if I want to get 2 or 3 would be as after slash home would be slash Wahid, and 4 would be the next one. So you could do that one, but at the same time, if you look at this line, so you could do something like awk print $1 would be just the first argument, which would be this argument, right? So I could do that one. That would give me. Let me just see what I did here. Awk let's print $1. So let's. Okay, yeah, because that one was not doing something like print ls minus L would give me a listing. So ls minus L, this is what is field 1. So if I want to do the number 1, this would be field 2. And if I want to do field 3, it would be Wahid. Field 4 is there. And then so this 3, 4, 5, 6, 7, 8, 9. So the 9 would be field the name of the files. And then if you want to just get rid of the this total, then you don't have this space here. So okay, you could just do something like here, your minus V total, and then do that one, and that will just do this. So as you can see that when you do this awk, you see this, and then you can say while read var do, and then say ls minus l d $sign var, and then say sleep 1 second, run a date command, and then at the same time I want to do the stat on the $sign var, and then done. So notice that 1 second, and then it gives a statistic on that file. And then, so with the auth, you can do a lot of neat stuff. Like for example, you could just say ls minus l grep minus I hello dot auth, and you could get this one, and then you could say auth again print $9, and $9 would give you the name of the file, and then just print it, or just say while read a var do cat minus n $var. So, and then ls minus ld $var echo. We are done with $var information. So let's say you got that one, and then say done. Now notice that the cat command minus n give you the line numbers on that file, then ls minus ld give you this line, and then the echo information is going to give you that. So awk is very cool programming language that you could do interactive Python, interactive Unix and Linux awk stuff. So I'm going to go to shells here. On the shells, as I mentioned, if you type in PS, these are all interpreters. So you have a Bourne shell, which is sh, and then if I say PS now, my $sign is pointing to Bourne shell. So if I say export name is equal Wahid, now I just created the export age is equal 100, and then now echo $sign name is and $sign age years old, and then you could say Wahid is 100 years old. I wish. And so that would be something like you could do on the fly, and then whether you do it on Bourne shell or Corn shell, all of these ones you could do like echo hello world, and then you could do that one. If you want to just write this one with minus e for expression, and you could put some new line characters, you could do that as well. Okay, there's 2 columns. I did not mean to write 2 columns. I wasn't seeing it, so it should be like this. And then if you want to tab here /t, so if you did this one in the Bourne shell, you could also write it, say vim t test1 $sh, and then wow, I already had a program named test1 $sh. So inside that one, I might have demoed something. So here you can write a script to just write it in bash, but this is in bash, not sh. So it does a menu, and I'm gonna just do another thing. So let's call it vim tt.sh. So I'm gonna say shebang user user ben env sh, and then I say echo hello world. So now I just did this one as a test. Now tt.sh is not executable. Why it's not executable? Because there's something called umask. Umask is 0.0.0.2.0.22. So for the file that gets created, usually it is something like this: 0666 minus the umask, and the umask in this case is 0.0.0. 22, which is gonna come up with sorry 22, which is equal to 0, 6, and then 4, 4, because 6 minus 2 is 4. 6, 4, 4, which translate to dash for regular file, read write for the first 6, and then no executable, and then read for the fourth, and then dash dash and read for the fourth, and that's how the permission is there. But if you have it as make dir test1, if you look at this test1 directory, test1 is in the case of Unix, ls minus ld test1, you can see that there's a directory and it's read, write, execute in this, read, execute for the others. So what it is, that one translate is that as 0777 minus the umask, which is 0022, and that is going to translate to 0755, and then that would be read directory first, read, write, execute, and then read read dash execute, and then read dash execute, because read dash execute meaning that 1 plus 4, that's 5, 1 plus 4, and write is not by the group and not by others, is not writable, only the owner can read and write and execute. So that is for the directory. So in this case, we did show that one, and now tt.sh is not executable. So if I run tt.sh, it says permission denied. The reason is because that file is not executable. If I run it with my Bourne shell, I could say sh minus x tt.sh. It will just load the Bourne shell interpreter and says, okay, this was the plus symbol that equal hello, and here's the output there. So if I do the same thing here, that would work, but at the same time, if I want to just execute it with bash minus x, would do the same thing. No matter what shell I could use it, I could still execute the shell since the syntax is correct. All those shells will load it into the syntax, and as long as you adhere to the syntax correctly, you will be fine. But I want to see not the plus symbol and all the other ones. So in order to do this tt.sh, I'm going to say change mode plus x and then tt.sh. Now tt.sh is executable. Read, write, execute, and then read dash execute, read dash execute by everybody. So that means I could just run it like this. And since the first line has the shebang user ben env, it's going to look for env. It's going to say, oh yeah, there's a binary called user ben env, and that binary is executable link format that says load the sh, where file user ben sh is there. So in fact, some user ben sh, I could have hard coded this first line to say user ben slash sh. This would have worked also. So when I say tt.sh, it would still work, but notice that I made a typo, and so tt.sh 1h and sh. And then now I run this one, it will work this way too, but I don't want it to work like that because it's hard coded. So instead of hard coding it, you want to load it through the environment. This will dynamically load it. So if your Bourne shell is not on user ben sh, it's on user sben sh, your program will not fail. For portability, you want to just write a code that is on every Unix platform. Usually env is on user ben env, so that is still portable. And then now tt.sh will work. Same way. So if I just change that one ben to tt.sh, and instead of this one, I could say corn shell. And then if I have which corn shell it is not there. Now it's run the tt.sh, it's not going to work because the conditional interpreter is not there. It's like asking the environment to load something that doesn't belong there. So I'm going to say sudo dnf install kernel shell, and then I'm going to provide my access for the switch user do command. Now kernel shell is installed, as you can see the package. So if I say which kernel shell, it's there. Now tt.sh is going to work also. So I could move the tt.sh to tt.kernel shell, it still would work because the syntax, the extension doesn't matter what it is. It's the head -1 tt.sh. That line, sorry, the kernel shell, I just renamed it. The first line, it says that it is a kernel shell syntax. So if I just change tt.kernel shell, and I just change that one to say, go to C shell, and then let's do that one, clear the screen, cat tt.kernel shell. Even though it's .kernel shell, I could say tt.kernel shell, kernel shell is going to just run the hello there, which is C shell -x tt.kernel shell also is going to say, well, the first line it says that load the C shell, and it's going to do that one. But notice that echo is too general. So if I just want to do something like this and say vim, let's modify it, vim tt.kernel shell, I'm going to call it tt.through shell. So clear screen vim tt.through shell. So I could demo that as well. And then I'm going to just write here and say use through shell. I'm going to say echo name is echo Wahid. And then since I do that one, I'm going to not do it this way. And I'm going to say set env, because the syntax is not export name is equal Wahid. It's the syntax is set env name on C shell and through C shell. So then I say hello $sign name. And then clear the screen now, tt.through C shell. It is just going to say hello Wahid. And then the reason it's working like that because tcsh is there. Sorry, tt.t shell is there with the env through C shell, and which through C shell is there. Even though I'm on Bourne shell, I could exit on this one, and I could be on bash, and then I still say tt.through C shell. That would still execute the C shell syntax. And then if I just copy this file tt.through C shell to say tt.zsh, and then let's see if I have zsh. If I have zsh, and then it doesn't matter what shell I am, and now I'm going to just modify tt.zsh here, and then change this one to zsh, the Z shell, and then I'm going to just take this line out, and I say for num and sequence $sign sequence of let's go to a few numbers. I'm going to just say something like a range of it. So 5 and then 5, let's say the end of it is 30, and then increment by 5 also. So let's see what we can do and say echo num is equal $sign num, just to do a small thing and then say done. And now say tt.zsh. It just says that because we did not do the step correctly. Vim tt.zsh, So now this time I'm gonna say that increment by 5 or increment by 7, let's say, and then go up to 30. So, and this time we run it, it's gonna increment 5, increment by 7, and then it goes up to 30. So if I just go again here and then increment it by 5, you can expect that it's gonna cover the 30 also. And then you can see that the range is up to 30. This is different than Python. Python range statement is working differently. So a sequence in the order that we did here, tt.zsh, if I just look at that one and I write a Python script, so Python 3 that version is just saying I have 3.96. So if I say go to Python interpreter, then I say for num and range, I have to say 5 comma 30, the earlier syntax, comma 5. That would say that go up to 25, and then say print num is, and then we could just say comma num, and then you could see that it goes from 5 to 25. Notice the range function, it is 30, the end is not inclusive. And the parameters passing it, the number of argument is 3 versus 1 is the end is at the end, and the other one is the end is in the middle. The step is 1 is in the middle, and the step on the Python is at the end. So that is a little bit different. So I'm going to exit out of Python here. We will come back to Python again, but we were talking about scripting. So with the ZSH stuff, you could do interactive Python programming or a hello world or something. So if I just say vim tt.zsh here, and then I say, well, just go for the sequence of 10 times, and then just say, let's go a little bit of space here, and we say this, and then at the same time, just the laugh out loud cat command, and then just write those numbers with that many times. And now say tt.zsh, and it will just say that. And if you want to read the argument from the command line, you could do that also. So vim tt.zsh, you could say, for example, right here, you could say while, actually rather while, you could say if $pound is less than 1, and then you want to give a usage. Say echo usage, and say $0, none. Echo example $0, $0, and then here we could just say example $0. Sorry, I need to go a num is let's say 5. So we could just get those done and exit, and then else we do this other for statement, and right here fi for the if statement. So if we do something like this, clear the screen, cat minus empty t.zsh, and if I run it t.zsh, it's gonna say you did not give me the number, so let's try the number 5, and it's gonna go 5 from 1 to 10. And then if I say 20, notice that inside our code, we hard coded the loop. So ZSH, let's just change that one right here to a sequence of $, whatever was the $1 would be giving the argument here as reading it. So I could put $1 into a num and then do it, or just use the $1 which is the first argument that's there. So if I just do that 20, now it's gonna go 20 numbers. If I do 5, it's gonna go 5. If I do 3, it's gonna go 3. And similarly, if I just wanna make it the code a little bit useful, I could just say here and say num in uppercase is equal $1, and then right here where I say sequence, instead of 1, I could say num in uppercase. So now clear the screen, cat tt.zsh, and then we say tt.zsh, and says that, okay, give me the number. I say up to 7, it's going to run up to 7, up to 100, it's going to just generate all the numbers with 100 and so on. So you could do within the do done, you could do all kind of looping. And then if event tt.zsh, instead of saying num is equal, you could say, for example, $num colon, say hello, hello world. Let's say hello universe, hello global, hello anything. So we say that one, and then between whatever number it does, we're just going to print that hello world that many times. So if I just run this code 10 times, it's going to say hello world 10 times. And if you say 11 times, it does 11 times. It does 5 times, it does that. So that's how you do it, okay? And then we have given you all the shells and stuff, a demo there. So we know there are different types of examples I gave different Linux Ubuntu or Linux Rocky or Linux Red Hat in this case, but programming is the same. And depending on your taste, at one point you may feel doing something, and then at another point you feel doing something. As long as you know what you're doing, you can write the code on the fly. And then let's get to the next one, see what we have there. So we want to go to the next one, PS, Red Hat, Rust, C++, Perl. Perl is also interpreter, so CD to Perl, practical extraction reporting language. And I have one script called for each.pl, and then which have a Perl. If it is installed, the user bin Perl, you could just execute it, or you could say env with shebang, user env, and then load that Perl. And then after that one, all the syntax that you write is syntax of Perl programming, like up to right here. So clear the screen, cat -n. Those are the syntax, line 1 through 9. So if I say run the for each.pl, it's going to just write hello Perl first, and then apple and pear, which is an array. Here it's giving it to the at fruits, and then for each item in my item, print the name of the fruits at array, and then a new line characters. So that's how simple that works. And then let's go to the next one, because we have a lot to cover. Ruby, and I believe Ruby is also Ruby. So Ruby is not installed yet, so I'm gonna do DNF search Ruby first to see what is Ruby, and then you can see here it comes in Ruby, a lot of the packages that are there. It will show you there. There's a lot. So clear the screen. I'm gonna do first sudo dash. I'm gonna become root first with switch user do. Now my ID is root. ID-UN is showing that. ID- group name is there. Uname. UN means user and name. GN means group name. So I did that one, and now I say DNF install Ruby. So I'm going to try to see if Ruby and gets installed. If I say no here, it does not get installed. So I could say which Ruby is not there. But if I say the DNF, I could use YAM or DNF interchangeably, because YAM is pointing to DNF-3 and DNF is also pointing to DNF-3. They're all using DNF-3, which is a Python 62 line of scripts. So in that case, cat -n, if I do which DNF-3, you could see file user bin DNF-3 is a Python script, cat -n user bin DNF-3, and that's 62 lines that I told you. If I say which YAM is pointing to the symbolic link or to DNF-3, and sorry, YAM is pointing to that one, and also DNF is pointing to that one. So whether you use DNF or YAM, it will use DNF-3, and then therefore I'm going to say, let's just update our system first. In order to do any package like Ruby installation or anything, I want to do something here first. So if I do pwd and ampersand, say echo this, it will just do that one. I run the pwd command as well as the ampersand. So instead of the echo this, I could say date command, it will run the date command. Instead of this one, I could say ls-l, it will just give me ls-l. If I say give me ls command, it will do that one. So, and then I say, while you do that one, another command calendar. Why am I showing you that one? Because those ampersand are very useful to run multiple commands. You can also run it with a semicolon and then disregard to whether the first command succeed or not. But you can also use the or statement, meaning if the first command succeed, you run it. If it doesn't succeed, try the next command also. Either one of them must succeed, it will execute that command. So in the case of this, now I want to do this. And instead of doing DNF update here once, and then semicolon, then DNF upgrade, I could do DNF-upgrade, update, and then and DNF upgrade. So it will run the DNF update and then say, yes, go ahead, do that. I could have typed in -y for yes for both of them, which I'm going to show you next. Then I don't have to be prompted. But if you didn't type it, you didn't automate it with the -y, then you have to be interactively typing a -y for yes. In this case, right now is doing the DNF update. Once the DNF update is done, now DNF-complete. Now this time, if I do that, when it says here, your system is up to date, it run it and fast and it just check it. And no matter how many times I run, if I say DNF update, it's gonna tell me your system is update, or DNF upgrade, and it's gonna say your system is up to date, or the combination of the two. On both of them, it says the system is complete. So now we have our system updated. We can do DNF install Ruby. That would install Ruby, and then I say, yeah, go ahead, install Ruby. I'm going to do a clear screen, which Ruby, and it's going to say Ruby is there, man. Ruby, it is saying that interactive object-oriented scripting language. So it's interpreted, but it is object-oriented programming language. So at this time, I'm going to go back to exit out of this one, since I have a Ruby available now. So I could say cd to programs. I think I'm already there. Yeah, so I'm already on the programs, cat hello.ruby. That is extension RB is for Ruby. A simple hello word, the comment is pound, and put this is the string that you want to say hello word. So you could say Ruby and then give the hello.ruby. It's like running a Python script by just saying Python name of the script.py. or Perl, the name of the script Perl. But if you put the shebang user ben env Ruby, then it will do the same thing. So let's just copy the hello.ruby to h.ruby. For sure, I'm gonna just vim h.ruby, and I'm gonna just put the first line with shebang user ben env, and then I could say call it Ruby. And now this is done, I could just execute it cat h.ruby. Notice that this one has shebang user ben env, so I could just say h.ruby. But this is permission denied because h.ruby is not executable. Change mode u plus x h.ruby. This time I didn't do plus x, I only want the user to have h.ruby executable. And now I say h.ruby, and it will just say hello world. So notice that the syntax is much like Bash and Perl and Python and other ones. So whatever you write on the Ruby script, you could do that one, or you could say Ruby h.ruby. This would run it, or just run it as executable RB, because we already put the shebang there. So similarly, that hello underscore ruby.ruby, it is just basically say hello Ruby. You could say Ruby and then hello underscore ruby.ruby will just do the same thing. But if I want to just do it with env Ruby like I did there, that syntax would also work. So the executable is not there, so change mode 755 hello underscore ruby cat minus n hello ruby.ruby. Sorry, hello ruby y. And then now all the lines are good. If I do ls minus l, you can see that file is executable. That means I could just run it, and it will load the Ruby interpreter and compile it and interpret it, and it will run line by line, and it works. So we're done with Ruby. What is the next one? Python. Okay, let's get to Python. Python is good too. So cd to Python. On Python, I have a lot of examples. Let's look at p1.py. What is that one? Hello from Python script. You could just say, so this one, if I say p1.py, it will just run that one in a for statement there. You can do interactive Python, or you could do it in a program there, or you could just say Python p1.py. It will do the same thing. So when you are running the code p1.py and user env, then you don't you make it executable, py will run there. And then you can also say get into the Python interpreter and just say print hello world, and then that would just do that one. And so you could say name is equal Wahid, and then let's say you want to just say what else we could write? Let's write age is equal 100 again, the same way that we did earlier. So I'm gonna say print name comma age, and then that would print Wahid 100. But if you want to write another, you could use the Python fstring function, and then if you start with double quote here, you have to finish it with double quote, and you could say, for example, hi, your name is, and then you could just write this brace around it, and you are this years of age. So you could do something like that, and then just do that one, and it will say, hi, your name is Wahid, and you're 100 years of age. So whatever you do with the Python and other ones, they allow you those things, and then with Python, you can get the directories and import OS module, SQL system, and then do a clear screen here. Clear screen is the clear command in Linux. OS.system clear. No system OS import. Did I import OS? Let's say import OS module. Import OS. Now it's imported. I wrote that right parenthesis for some reason. So I do this one and will clear it or not. OS has no attribute. Let me just quit out of this one. Something must have gone wrong. Python 3, and then say import OS module, and then OS.system, and then say clear the screen command, and then that should be it. Yeah. And then if I just want to say run uname -a, I'll give me output, run the calendar command, run the date command. So everything you do, this one, and then now I want to clear the screen here, just that one, and we'll just do it. Exit out of Python, and there's interactive Python also, IPython. That I'm sorry, IPython might not be installed. I can install it, and so yeah, I'm gonna say. Let me see, Jupyter Lab is installed or not. Which Jupyter Lab? It is not installed. So, which pep is not installed. So a lot of the stuff I have to install. Sudo dash. I don't want to get this video too long. Unfortunately, I'm running out of time. DNF install pep. And go ahead and install that one, and then pep install IPython, and then that will install the IPython. Pep install Jupyter Lab. Now install all of them. Look how fast it is with nice stuff that is available within these modules, so that you can do that one. And then so clear the screen, and then if I just say which IPython, it is now available with, and Jupyter Lab is there, or and Jupyter maybe dash lab, Jupyter dash lab. Yeah, it's there. So I could open another terminal here and go to IPython, and then that's interactive Python. I could say aliases, clear the screen, aliases, and then ls command. You should see those aliases are there. Ls magic, the list of the magics, whether cell magic or line magic, all of these are available within the cell magic or line magic. And you could go to Python 3 or Ruby or other ones inside there. There's a lot of stuff here. You could still do import, let's say, math module, and then math.py, and generate the py one math dot, let's say, power of to the power of 10, and then get that power math dot square root. So a lot of these function 49. Like 7 and so on. So I'm going to exit out of IPython, and then similarly you could say in Jupyter Lab to get into Jupyter Lab. That opens Firefox in this case, or Mozilla, whichever one is the browser, the default one. It all goes to localhost port 888, and then inside that one you have Python 3 kernel, as well as console, as well as terminals, text file, markdown, Python files, and a lot of other ones. So if you go to any of these tabs and you want to just work on it, just open the cell, and you could do the same thing with pound ls magic, and you could get the list of magic. If you just click on this run, you get the lines and cell, as well as aliases, to get the alias there. And then here you could also do, for example, let's say create a list here. I'm going to say commands is equal create a list, and then I'm going to say run the host name command as well as pwd command as well as the calendar command. These three commands, and I could say for CMD and the list commands, I could say I had to import the OS command first because I want to run those commands here. So if you do this one and you did not import it, notice if you say os.system, os.system, and then you say run the command CMD, it's gonna fail because we haven't import OS module here. And notice this is gonna just run this error. But you can go back to the cell, and right here where we did it, we can just say import OS before we use os.system function call. So now we run this one and it runs those commands. And if you just run another command, whatever command was there, and instead of pwd, we could say date command, and then just don't give that calendar command. You could just run those two commands, host name and date, and run it, and you will see the output, host name and date, and there. So this is here. You can also shut down this one by just going under file and go under shutdown if you're not using it. Since I have to demo other stuff, I'm gonna exit out of this one. Actually, if you want to use NumPy and other ones, by default, NumPy is not loaded in here, and so you just have to. It's a little bit tedious to just interact with this. The screens are just flickering. Let me just move it slowly. So file, and then move this one slowly. No matter how slowly you want to go. Maybe I have to use it this like that. Shut down, and then say yeah, shut down. So this one clear the IPython or Jupyter Lab in this case. So if I want to just use pep list, these are the modules that are there. Notice that grep -i numpy is not there. So and then but some modules like requests, it might be there already. It comes with it. The regular expression is already there. So if I just import the regular expression inside Python, that's a standard, but NumPy is not. So in order to use NumPy, I have to say pep install NumPy, and then now NumPy is getting loaded. And like I mentioned that when you do the interpreter, the NumPy module was pre-compiled in C. It was written in native C, so and the data type that is doing it's homogeneous, so it's much faster. And then rather than a list that is not like an array of C++. So in this case, now NumPy is installed. So if I do this one, it shows the NumPy version that is there. And I could say, for example, Python 3, and then import a NumPy as NP. Now NP is there. And there of NP, you can see all the modules that are available. There's thousands of them. I have at least 6 or 7 videos on this one, just on NumPy. Please watch those ones because it would be too long for this video. So let me get out of Python. I'm gonna just move fast on the rest of them. I'm gonna go to C++, and then on C++, you can see here I have a C program called hello.c++. Clear screen cat -n hello.c++. Since it's a C++, it uses IO stream. The syntax, I'm not going to introduce you the whole thing because I want to do it faster. G++ is the compiler. As I mentioned, -- version, it tells you that I already have it. So G++ minus O for output executable file, hello, and then hello.c++, and file hello is there now, is executable link format. Hello is that gonna just run that output. So that is for the C++. Let me just go to the directory. I'm gonna just open another one. So I am on the Python. I already did the C++. I'm going to do C. So now GCC is the compiler for GNU C collection compiler. So when you do this one, it tells you that I have that version, and then if I just say cat -n hello hello.c, it uses standard io.h, and in main printf function, and then I'm gonna say hello as output. It just does exactly that, because I did create hello earlier. If I just say gcc -o hello, and then hello.c, that will just generate hello. But if I just don't want to give it an executable name, I could say gcc hello.c. It creates this a.out, which is a.out is the same as the executable that is there. So file a.out will just give the same kind of output, except the name is different than hello. So you want to give it a name, you have to say the dash code. And there's -g for debuggers for both C, C++. I have already shown those ones on other videos. So I'm going to move on to the next one, which is Go language. Go language, let's look at that Go here, and then which Go. Go is not installed, so in order to install it, I'm going to go back here on the root, and then I say DNF install Golang. Golang will be installed here, and I say yes, go ahead, continue. And then Golang, Godoc, and Go will be the binary that will be available, as you can see here. All of that one will be available. Then I can compile the Go language by saying Go run, and then Go doc, and then get the documentation, and then all of that one you can do it. I'm showing you on Linux how-tos, the default or standard way of starting with something. As long as you have the compiler and have the source code, you could write everything yourself. So here and now, Go language is installed. So I say which Go, and then which Go lang is not there, which Go doc is not there, but what you could say Go doc and then FFT. That would give you that information for this, or FFT dot print line. So you could get all that one, or scan it or something as print command, as printf function, and that is also available. So all of those ones are available. And then here we have a program called hello.go. In order to compile it, you say go run hello.go, and then it will just do hello world. Whatever is in the printf statement, it will format it, because we import that format module, the package is main, and so on. So it supports Go programming as well. We just install it. So let's see the next screen, what we have here. Java, CD to Java, and then Java, let's see if we say which Java is not there, which Java C is compiler is not there. So I'm gonna go back on this tab and just say DNF install, and rather than install, let's search for OpenJDK, which version it is available. You can see that it is OpenJDK latest JDK, or something with default. So we can say DNF install Java latest open JDK. That's good enough to find out the JDK version, and then we do install it. A lot of these ones have their own documentation and everything. So when you install it, then you see the name of the package, then you can grep out /bin on the RPM-QA list, or just list it on the package name, and you know where it is. Or if you know the name of the binary, you could just run the name of the binary, say which on it, it will tell you. So now it is getting installed. You can see it is there, which Java is there, which jar is there or not, which Java C is there. So let's see which Java C, how come it's not there? So something did not get installed properly because of the OpenJDK, the one that I did. Maybe I could say Java Open JDK. If we just do that one, see if, yeah, no match found, open JDK. So in this case, I have to search for it to see what is the name here. DNF search, and then for JDK or Java. Let's see what is showing on Java. And then let me search for grep -i default. Grep -i. Grep -i open JDK. So another thing you could do is say DNF provides Java C. Java C is the compiler we need. So once you get that one, you can see around 9 RPMs there is the name, and then let's see what is 5 more. Java C, Java 11 open JDK. So clear screen, DNF search, and Java 11. Oh, I forgot the name. One more time, sorry. Java -11 was it? On open JDK. Java -11 open JDK. So I'm gonna say DNF install Java version 11 open JDK. And then let's see if that, yeah, that install it, and most likely the Java C compiler is there, because I did DNF provides, and it did show Java 11 provides that package. So now if I just say which Java C, again it's not there. Open JDK is there. RPM-QA to L, grep QA grep -Java. Let's see which one were there, and then I'm gonna say on all of these ones, well, I read by var do, and then I'm gonna say RPM-QL and $var grep -i Java C. Let's see if Java C is anywhere. No, it's not. And instead of that one, and if I say Java is there or not? Yeah, Java is there, but I want to see if the binaries are there. Java binary is there. Alternative Java is there. Java, which open there Java. One alt man alt that Java. Launch the Java application, Java. That's on the Java, and then it uses the jar file also. Man Java C is not there, so I have to do a little bit more work on this one. Let me see what I have done on the uh, on WFP, and then I'm gonna um, DNF search and JDK. Maven GDK, Open GDK, and one of these tools must have it beside the DNF provides a Java C. And let's see what other ones I look for. This RPM user bin Java C. So I'm gonna try that one. And DNF install RHEL-9 RedHat 9 for x86 underscore 64 and dash upstream dash RPMs. So that one requires a package and no match found. So let me just see if the upstream is available or not. And then we say DNF repo list. And the extra packages are there. The EPAL is there or not? I don't see the EPAL. Yeah. So let me just go to home WLotfi programs, shells, and home Wahid, no, Wahid, and then loop demos, and then cut eval.text. And then now I'm gonna do this DNF install RPMs. Copy and then install those RPMs. It's already installed. When JDK, I did install it. Maybe it's the default one. Let me just see what is the default one. Give my message default. And this is this from every system. Sometimes Red Hat just have a different version for it. It's tedious to just search for it this way. Let's do that default. So getting those 64 JDK develop. I'm gonna try this one development. So say open JDK 11 development environment. I'm gonna say DNF install and Java 11-open and JDK-develop. That would install the development. And I say yes, go ahead and install it. And let's see if that one Java C. Yeah, that development, you had to install the development version of it. The JDK 11 we installed it, but it wasn't available. So I installed the JDK dash the Open JDK Java 11 Open JDK dash 11. That is done. So now I go back here on this one, since I say which Java is there, which Java C is there. So now I can compile my code. Hello, hello.java is there. I'm gonna remove hello.class, which is the bytecode. So I'm gonna say cat minus I did already cat it, and so I'm saying Java C and then hello.java. That would create the hello.class that I just removed, and now say Java, the virtual machine, and the name of the byte code, and it's going to say hello, and it's going to say the same thing. So similarly, if I just say rm f.class, and then cat f dot Java is the source code. I'm going to say Java C f dot uh, of the Java. It compiles it. Now I have a file called um, f dot Java, which is source code. It shows as a C++ code, and then the Java compile bytecode is f dot class. So in order to run the f dot class, you say Java, the Java virtual machine, and then f that would run the code. So that's it for Java. Let's go to the next one. JavaScript is a different topic. I'm going to cover some of them. But if you say install Node.js, you could just go to the JavaScript. And just as a demo, I'm going to just show you a quick thing. So hello, is hello there? I don't have a hello function program, but let's say something.js here, got demo1.js. If I say demo1, demo is running, and then console.log, so I could say node, and then the name of the script called demo1.js, and it's gonna just run that. So that's how it is done in Node, using Node. So any function that would like cat for demo1.js, it is that. And then if I want to just use that one, because I'm using a print statement, it may work differently because that is inside there. But if I say node and then for demo1.js, it will just not do it because those print lines are not an example of the way you're using the Node.js. But now watch the same file if you do HTML. So cat for demo1.html. This one is the HTML that uses Java inside of it. So you need like Firefox for demo1.html. It will open the HTML page, and it is going to just do this syntax, and it's going to say document, and the for loop is there, and then the output is there. Okay, I'm going to close this one. Let's just jump into the next one. There's JavaScript, and other ones are pretty easy. You could do it. You could also get it to Node and just say 2 plus 2 is there, and then say, for example, write a hello function. You say function hello, and then here you could say console.log, and then you could say hello world, and then close this one. Now we wrote the hello, it is just going to just print that. And then when you exit out of this one, dot exit, it will exit out. So we're done with that node in JavaScript. On a subsequent video, I may cover more, but let's just make sure that everything here we got is covered. So JavaScript, JS, NASM. NASM is not the one that I have covered. Everything else I covered. Rust, I think I have not covered. Let me just go to Rust. So hello.rs is there, which Rust is not installed. So again here say clear screen DNF install Rust. That will install Rust, and then say yes, and then come back here once installed. It is doing 3.5 gig megabyte per second. Okay, it's done. So now I say clear screen, which Rust, and then man Rust. Oh, which Rust C? Rust C is the compiler. Man Rust C, you can see, is the Rust compiler, and then which Rust C is there. So now we look at it, Rust C hello.rust, and it's going to execute it. Cat, I mean the hello program got created file hello there. So if I remove hello there, every time you compile it like that, it will just create a hello program, and then hello will just run that. Okay, so that is for Rust, and then the other one that I have not covered is NASM. And so with NASM, let's go to NASM for assembly language. Here I have a number of codes. So I'm gonna say sudo, actually let's do a sudo here short. Sudo and DNF provides */* NASM. See what provides a NASM, and then I say type in the password. And then that's some of the information, but I don't think that is that. So last time I had to do this NASM info, and this script, I'm gonna just, if I say sudo DNF install NASM, it's not gonna work, I believe. Yeah, it is giving actually on RedHat, but it did not work on the Rocky version. So which NASM now it is available. So all I had to do is run this command sudo DNF install NASM. On the Rocky, it did not work, so I had to do NASM-info and then do a DNF sudo enable as a repo is equal development. Again, sometimes the development version is going to be available for you. Install NASM, that would also work. So now, which NASM is there, I have already written this hello.compile file that is going to help us compilation. Part of it, you can run your own make to include all of that code in one shot or automate it. But here, I want to show you the steps. So you say NASM, and then -f, you execute a link format, and then hello.asm. That would create a hello.object file. So let me just remove hello.object first, and then now I'm going to say NASM, and then -f execute a link format elf hello.asm assembler. Now I created the hello.object file just now. As you can see, that timestamp is today, August 15th. So now we could just say run the assembly code, which AS, and then you say run the assembly code -o hello.out as hello.s. And then now it is giving you that warning. All we have to do is which loader, the link file user pen LD is that LDD user pen LD. You can see the symbolic link of all those shared object files that are linker. So you could say the linker is after we did that one, LD-L-S-O output file, and then hello.s. So sorry, cat is not the command I want to use. So LD-S-O hello.out hello, and then hello.object file. And now hello is created, file hello is executable, link format, and hello will give you the output. I hope you enjoyed it. I hope you learned something from it. If you didn't, just repeat the video again and again. You will learn a lot from it. And I covered a lot of different topics, a lot of different compilers, and a lot of different interpreters. And there's 3 videos now. We are going to post the 3rd one tonight, which is going to be this one for the Linux Ubuntu. These 2 are already there. I hope you subscribe and make some comments so I can improve it and meet your needs. God bless you all. Take care. Bye-bye.